All right, time for new filament test. JAYO. We did JAYO PTG that should be already posted. This is JAYO PLA, PLA plus they say. So it's comes from JAYO obviously. Here's some information about the different kind of PLAs they have and other filament types. We've only used the PTG, and uses recycled packaging. It says it's tangle-free, bubble-free, smooth printing, of course. Tolerance of 0.02 millimeters. That's pretty good. Let's open this up and see what the reel looks like. Oh, one other thing is that these reels have 1.1 kilograms. You're getting an extra 10% of filament, which is actually significant. So that could make a difference on some. A lot of my things I'm doing where I take a couple hundred grams of filament to print. So if with 1.1 kilograms, I'm able to get one extra print out of a reel. So I'm doing things from production, and I print a bunch at once. Not having a remnant at the end of the reel that I have to figure out what to do with could be a big advantage. So just using a cardboard reel like most vendors have switched to. So again, it says 1.1 kilograms, 2.4 pounds, 1.75 diameter. It's got some kilogram marks here. That's okay, it's better than nothing. I always use my scale. Neatly round filament, fits for most FDM 3D printers, and again, 98% tolerance, plus or minus 0.02 millimeters. There's a nice vacuum on it. Let's open this up. All right, so this is made in China. It's got a nice black sheen to it. So the question is, why am I using this filament? I have been using another black filament, which I've had a review of, which is this FilaCube. So FilaCube is great. It's made in the United States. It's prints super smooth. I never have a problem with it. My favorite filament. But this costs about $24 a kilogram. And this was on sale, but I think the list price is about $14 or $15 a kilogram. So it's about $10 cheaper per reel. So the thing I'm printing, which I'll show you in a minute, we'll do as our final print, is a dice tower that takes many hours to print, and which means I have to charge a lot for it. So I'm hoping with this cheaper filament, I don't sell a lot of them, but I like to have it on my Etsy store. I don't sell a lot of them, but I'd like to lower the price a little bit. Maybe I'd sell a few more. So I'm hoping with this filament, I can lower the price by $5. So we had good luck with the JAYO PTG filament. That's why I was willing to try this. It wasn't quite as good as the California Filaments PTG, but it was, it was okay. And it wasn't that much cheaper, or actually it was about the same price. So it was a good backup. California Filaments has been very reliable. I haven't had any problem getting filament from them, at least not black anyway. That's their favorite color. Anyway, we're going to try this and see whether we can get a good print out of it. All right, so we're going to weigh this and see if we got our money's worth. So we're going to weigh the whole thing here. And it says 1,224 grams. So I don't, this is the first reel I've got from this JAYO guys. So I don't have the exact reel to do a tear on. But I do have this California Filament cardboard reel, which looks basically identical. Slightly different. These holes are slightly different, but the cardboard filament is a lot less variation in the cardboard filament weights. Let's weigh this. This is 138 grams, so we're going to make that our 0 by hitting the tear button. Now that's going to subtract that from this, and and this says we have 1085, so not quite 1.1 kilograms, so 15 grams under, which usually most manufacturers say plus or minus 50 grams on their net weight. So we'll see if we're all done. We'll see how much this thing weighs, the cardboard, and we'll be able to tell exactly how much we got. So we are getting more than we get with a 1 kilogram reel. So hopefully that'll make a difference. One other thing about this JAYO PLA is that it has this little print tag or filament tag. These are super helpful. Just leave them on here. It makes it easier if you lose control of the end of the filament, then you can recover it before it gets tangled underneath one of these other layers. So I would say this is wound pretty well. Not perfect. So we'll see how that goes.
All right, so here's our temperature tower in OpenSCAD. This is called a pointy temperature tower. It's my favorite temperature tower test. I modified it slightly and uploaded my own version to Thingiverse, so there's a link to that in the show notes. It just puts the PLA or PETG, whatever you're printing, over here, which is kind of fun. In any case, this is a new filament, so we're going to print a little wider than we normally do. So we're going to go from 200 to 230. We've been printing all of our PLA except for one manufacturer at 225 with good results, so hopefully that's what's going to happen. But we're going to go ahead and test all these different temperatures and see how it goes. So we can go ahead and render this. So it's already rendered, and then we'll just save it to an STL file, and then we'll load it into Simplify 3D and set it up to print. Oh, I should go over this a little bit, how this works. Okay, so you set the end temperature, which is the coolest temperature, and then you set the starting temperature here, and then you set the temperature steps. Every 5 degrees, it changes it. And you always put the highest temperature at the bottom, so you have less likely to clog, because at the lower temperatures, at some point, the filament's not going to flow, it's going to clog. So you want to start at higher temperatures first on the bottom, and then transition to lower temperatures. Okay. All right, so here's our temperature tower in Simplify 3D. And so I'll show you how I set up the process for that. So we need a temperature gradient that'll change temperatures as we go higher in the tower. But the basic stuff is this is PLA, so nozzle diameter is 0.4, extrusion multiplier is 0.9 for PLA. I use 1.0 for PTG. Traction speed of 1200 works for me for cutting down on stringing. And we're using 0.2 millimeter layers. And we're using 3 solid layers on top and bottom and 2 perimeter layers. Now for the first layer settings, I use 90% for the first layer, which helps squish down so it sticks better. Lately I've been using 100% for the first layer width, so it doesn't get an extra little elephant's foot, they call it, sticking out. I have it at 210. Now let's leave it on that for now, because we haven't used this before. And first speed layer, 50%. The default's 35%, but I found that's not necessary. It just slows everything down. So 50% works good. Works well for sticking to the first layer. So, and we're not doing any other additions. And the infill, we're doing 20% infill and 50 rectilinear. It's going to ask us about supports, but we don't want to do supports. We want to see how this bridging works. That's the whole point, one of the points of this test. For temperatures, we need to have a temperature gradient that changes. So the way this model works, the first 18 layers or 17 layers are this base. And we're starting with the highest temperatures at the bottom so that it has less chance of clogging. As you go to lower temperatures, it might start clogging. At some point, it will clog. So you want to get sure the temperature outputs as far as it can without having problems. So the way this model works is once you get to the base, then every temperature tower or temperature bridge here is 35 layers. Just the way it works out with 0.2 millimeter layers. So Simplify 3D makes it easy to set up this gradient. So you just put in the layer numbers. You can add a new one if you want. And so the base is 230, and then the first bridge is at 230, and then 225 all the way down to 200. And then for cooling, for PLA, I always have no fan on the first layer and 100% on the second layer and all of the layers. For speeds, I printed 3600. That's the default for PLA. And the travel speed I set at 4800. And the other thing I do for advanced, I allow single wall extrusions and allowing gap fill. That just helps fill in small areas that doesn't leave them open. So this is version 5 of Simplify 3D updated recently, so it's 5.1.1. I started out using version 4, and most of my projects are still on version 4. When I first bought version 5, the upgrade procedure didn't work for a lot of my projects. It wasn't able to convert the profiles because they're slightly different. Some things are slightly different as far as setting things, and some other problems. So new projects, I try to use version 5 unless I have a problem. It does do some things better, so some projects I have moved to version 5 to get advantage of the new features, like more complicated infills. But this is a simple project, but I'm using version 5 because it's a new project. Let's go ahead and slice this. So it's going to ask us about supports. Do you think it needs supports here? We could adjust the parameters so it doesn't think it needs supports, but so we're just saying we don't want to do supports. We want to see how the bridging works. And so this is going to take about an hour and 15 minutes and take about 7.5 grams of material. So go ahead and send this to an SD card so we can put it in our printer. And we'll see how it goes. Our first test of the new JAYO Black PLA.
All right, it's done. So we're testing two different things at once here. We're testing this new PEI print surface. We're also doing a temperature test on our JAYO PLA. So let's see, this just comes up with my fingernail. Some of the reviews I said about PEI is that it's kind of fragile. You can scratch it. I'm not sure that's true with this this kind of surface, but we're going to take this off. Take it over the workbench and try to take off this print and see how it turns out. So this is still a little bit warm. Flex it, comes right off. So the bed adhesion was good. There was no problem with sticking to the bed. I would say it came off more easily. It came off easier than the sticker. This is a pretty small surface, so it's hard to tell. I would say the jury's still out, but I would say it came off pretty easy. Look at our temperature bridges. So remember we started at 230 and then 225. So we can look at these little, actually it looks like it prints really well at all temperatures here. Look at the back. I don't see a lot of sagging, so this filament, this is probably one of the better temperatures that I've ever printed. There's a little bit of blobbing, so that's just the last one. Ridge strength is good. So this looks like it prints at a wide range of temperatures. So we like 225. I hate to worry about, oh yeah, this filament is this temperature and that filament's another temperature, so I try to print everything at the same. 225 is good for me because it doesn't, the filament flows really well. You don't have to worry about clogging. So we'll go ahead and print our bed and layer adhesion test at 225. And I don't think I mentioned in the video about setting up this print is that the bed temperature was 50 degrees, which results in 45 degrees here. So that's what I printed this at. It had good adhesion. So this surface impresses me so far. There's no mark on it, no residual, which often with this, actually after, when it's brand new, there's not really much residual, but there's always some residual. And then over time, you get more stuff stuck to here. I don't know if you can see that little shiny, that's filament that's stuck to it. That I usually use this 150 grit sandpaper to get it smooth again, so that works really well. Now for this, what I've read is you can clean it with isopropyl alcohol, which I have some of that. And I have 91%, that's what I probably would use. And it says you can also sand it, so we'll see. Not doing anything yet, so we're just going to leave it alone for now. So go ahead and print our bed and layer adhesion test, and hopefully that'll work.
If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.